Okay, so we're going to we're going to look at one last way to graph, and that is using the intercept. And we've talked about the y-intercept already, okay? So there's a picture, and if you look, the bare things you need to graph are only 2 points. So you can get the 2 points by using the intercept, and that's what I'm going to show you in a second. But you'll notice for the y-intercept, you'll notice that your x value is a 0. And for your x-intercept, your y value is a 0. So let's take a look at the equation here. So we're going to find the y-intercept, and then we're going to find the x-intercept, but we're not going to put it in slope-intercept form, okay? So you're going to take the equation, minus 5y, right, equals 15. Some people also call this the cover-up method, okay? So I'm going to take the 3, and I'm going to find the y-intercept. I'm going to plug a 0 in. So basically that 3 times 0 is nothing, right? So all you're left with is negative 5y equals 15, right? So the way they say cover up is you just cover that up, and you got a simple one-step equation, right? So you have negative 5y equals 15. Divide. So y equals negative 3, because that's the y-intercept. Because again, x was 0, right? And y is negative 3. So you could plot that one, right? That's going to be here. Now, the one we haven't talked about much is the x-intercept. So we'll take the equation again. And this time, if we're going to find the x-intercept, we're going to plug in 0 for y this time. Basically takes that away, right? Because anything times 0 is 0. So you'll be left with 3x equals 15, right? So x is going to equal 5. Well, that ordered pair, right, would be 5. Remember, we made y 0. Okay, so that would be 1, 2, 3, 4, 5, 0. And there's my line right here, right? Now, if you wanted to continue on a little longer, right, or just make the line bigger, all you could do is find the slope. You could count the slope, couldn't you? You go 1, 2, up 3, 1, 2, 3, 4, 5, right? So if I had a little more room on the graph, up 3 over 5, or I think I could go down, couldn't I? 1, 2, down 3, 1, 2, 3, 4, 5, right? Let's do that again. 1, 2, 3, 1, 2, 3, 5, right? Okay. And there's my line. It's a good method to use, however, the only thing is that sometimes if you don't get an integer, then it's not the best to graph, because you'll have to use a little estimating. That's why still using slope-intercept is the most exact way. All right, so let's take a look at a couple of quick ones here. We could probably do this real quick. All right, let me make this a little bigger for us so we could see. All right, so we're going to look at the first one here, right? And we want to find the x-intercept. What do we make 0? The y, right? Ooh, that's a tough problem, isn't it? 2x equals 2. So, x equals 1. That's the x-intercept, right? Okay, now if I want to find the y-intercept, I make the x 0, right? So that's going to be 2 times 0 plus y equals 2. Wow, that's a real tough one. Y equals 2. So those are my two intercepts. Let's graph them, right? So you got a really small line, but again, it's going down. You could check it out. So look, you start here, you go 1 down 2 over 1. So down 2 over 1 would be my slope. So I want to make my line a little bigger. I'm going to go down 2 over 1, right? Let's do a little more. Down 2 over 1. You get the idea. We go backwards 1, 2, up 1, and we're finished, right? Seem pretty simple, I hope. Let's look at the next one. So we'll start with the x-intercept again. So we're going to make the y 0, right? So again, that's going to knock out my y value. So I'm going to get 4x equals negative 20. Ooh, tough equation, huh, guys? So x equals negative 5. All right, there's my x-intercept. 1, 2, 3, 4, 5. Let's go ahead and find the y-intercept. Here, we'll do it over here. We got some room. So now to find the y-intercept, we're going to do complete opposite. We'll make the x 0. All right. So now you're going to have negative 5y equals negative 20. Divide by negative 5. The y-intercept is 4, right? The y-intercept is 4. 1, 2, 3, 4. You could tell you are going up positive, right? 1, 2, 3, 4. 1, 2, 3, 4, 5. So the slope is 4 over 5 positive, right? All right, number 3. Wow, this is real easy. All right, x-intercept, right? Make the y what? 0. X equals 4. Boom. Y-intercept, right? Make the x 0. What does y equal? Well, y equals 4 also. Okay, so 1, 2, 3, 4. There are my 2 points. I have a negative slope. If you wanted to find the slope, 1, 2, 3, 4, down 4. 1, 2, 3, 4, over 4. So 4 over 4 is actually what? 1 over 1. So down 1 over 1 if I wanted to make it a little bigger, and then I could go backwards here. Okay. All right, last one. Let's go ahead and find the x-intercept again. Find the x-intercept, we're making what? 0. The y value, right? So the y value is 0. All right. So I got x equals negative 6. Let's plot it. 1, 2, 3, 4. Whoa, just ran out of room there, right? Last one. All right, to find the y-intercept, what goes 0? X, right? All right, so I am left with negative 2y equals negative 6. Well, half of 6 is 3. So the y-intercept is 3, right? Again, that's a negative over negative. That's why it's positive. 1, 2, 3. There I go. What kind of slope, guys? Positive, right? Let's find the slope. 1, 2, up 3. 1, 2, 3, 4, 5, 6. 3 over 6 would actually be what? A half. So that would be up 1 over 2, right? If you wanted to continue. Positive slope. I'm done. So again, this was graphing using the intercepts. You notice all our intercepts were nice and pretty. They're not always like that. That's why we have the option of putting them in slope-intercept form if you want to.